is there anybody who wants me to go through B and D? We skip those. Is there anybody who's like, I really didn't? Yeah.
Could you go over B, please?
Yes. Okay. Let's look at B. So for part B here, again, our general formula that we were working with yesterday was this S equals your first term divided by 1 minus your rate for your R. I shouldn't call it a rate. It's a common ratio. So my A1 is right here. And then my R is going to be equal to this term divided by that term, which it's nice if this is 1 because it's just going to be end up being that second term. So it's -3/4. So when I plug this in, it would be 1 over, and then this ends up being 1 plus 3/4 because it's minus a negative.
So,
No what? There is a sum here because the 3/4 is less than 1.
I got it.
Yeah, you're just looking at your R.
Okay.
So this ends up being 1 over 4 over 4 plus 3 over 4, which is 1 over 7 over 4. And anytime you have a triple fraction, you should be thinking keep, change, flip, actually, or a 4-layered fraction. So this is keep, change, flip would just be 4 over 7 as a final answer. Yeah, because you keep the top, change the division, this division to multiplication, and then flip this. So it'd be 1 times 4 over 7. You guys want me to do D? No, we're good with D? Okay. Let's look at the really cool one. Example 3. I really like this application for series. It's kind of crazy that it exists. So this wants us to write 0.242424 repeating as a fraction in lowest terms. And it turns out we can do this by writing it as a geometric series. So let's think about first like breaking this number up. You can break this number into 0.24 plus 0.0024 plus 0.00024. Do we all agree that this, just these 3 gives us this? We all get on board with that? Okay, well, when you have it written like this, we can actually write this now as a series where our A term is 0.24 times, not 0.24, excuse me, 24. 24. Yes, 24. I know, it's weird. 24 times 0.01. That would move your decimal back. Plus 24 times 0.01 squared. Plus 24 times 0.01 to the third. Plus ... You guys see it?
Yes.
All right, so now that this looks like a geometric series, let's take that sum and we'll plug it in. My first term is this whole thing. So it's 24 times 0.01 over 1 minus my common ratio here is 0.01. Just as a point, because when I was looking at this, I was like, well, I thought the first term would be 24. Your first term here is whatever is given to you. And maybe if we had written this as a series, it wouldn't be at I equals 1 necessarily. This is at I equals 1, but your first term might not necessarily, but that doesn't matter. It's like the first thing we see here. So now if we just simplify this, you end up with 0.24 over 0.99. Does anyone remember we don't like decimals and fractions. That's like, that's weird. How do we get rid of the decimals?
Multiply by
100. Yeah. So basically you multiply it by whatever gets all of your decimals gone. And I say all of your decimals just because you don't have to write this down, but like say you had something like 0.1 over 0.01, then you'd still multiply by 100 and you'd end up with 10 over 1, something like that. That's so even if your decimals don't match, just get rid of all of them. And I think that comes up in one of your homework problems. Then we need to simplify. What divides both 24 and 99? 3. So this is the same as 8 over 33. Yes.
So if she would have done 0.2 plus 0.04, and like, would that have given you the same thing?
0.2 times 0.4.
Oh, no, plus like how we did it.
Oh, plus,
Or would you have to group the numbers?
you have to group the numbers. So you can do that if you have like 0.7 repeating, it's one number. You can do that. I think you'll see in the homework problems, you'll start to see some patterns. There is, I know number 7 is pretty tricky. So I'll give you a hint if you get stuck with number 7, but I want to let you guys kind of wrestle with it for a minute.